Hi. In today's lesson, we're going to use factoring to solve quadratic equations. So let's get our name on the top, as we always need to. So the issue is continuing to be able to solve for x. But if you are handed an equation that looks like standard form, ax squared plus bx plus c equals 0, you can't just draw a river and then solve for x. You have two of them, and it doesn't work very nicely most of the time. So there's another method that you just got to have an arsenal of methods of how to do what to do. So we can't just solve for x. So we're going to factor and then set each piece equal to 0 and solve the pieces for x. So we've spent a lot of time factoring, and becoming a master at factoring makes this really easy, very friendly to work through. So hopefully by the end of this lesson, you will have super strengthened your skills in factoring, but also now have a reason to use them when you're looking for the x-intercepts of a quadratic. Remember, there are still 3 other names for an x-intercept. One of them is based around the word solve, so that would be a solution that you solve for. Remember, there are also roots and zeros. Why do they use the word zeros? Because you have to set this equal to a 0. Good. So the zero product property is telling us, really, if you have these two binomials, then you can set them equal to 0 and solve for x. That's the zero product property. So you draw the river, subtract 3 on both sides, and there will be an x-intercept at x equals -3. It's a done deal. And then for the other binomial, again, you draw the river, you solve for x, and there will be another x-intercept at x equals 2. It's a done deal, which is why this is really nice. It's very simple, very friendly to work with, as long as you have your factoring done. So let's go look at problem number 1. So problem number 1 is already factored for us. That's really great. And you're going to set your factored binomial equal to 0. So now let's go solve for a. Subtract 2 on both sides of the river for a equals -2. Divide by 4 on both sides of the river, and a equals -1/2. So there will be an x-intercept, a root, a 0, a solution at -1/2. That was pretty great. So now let's take care of the other binomial. We have a minus 6 equals 0. Let's draw the river. We need to get a alone, so just add 6 to both sides, and a equals 6. So again, it will cross the x-axis at 6. And also at negative 1/2. Done. Wasn't that great? So easy. Why don't you take a moment and try to do number 2. Pause the video. Okay, problem number 3. So in problem number 3, yes, my quadratic is equal to 0, which is a requirement. However, it is not factored. Well, that's not a big deal. Let's go factor it. We can do this. A, B, C. What's the value of A? Good, it's a 1. What's the value of B? Yep, it's a 3. And C, you got it, negative 18. Let's draw our box with the X in it. What goes on the top of this box? Remember? A times C. So we have 1 times a negative 18, which gets for us negative 18. And what goes in the bottom triangle? Good, you remembered it's B. And that's a 3. Nice. So now let's go build our t-table. I have a negative 18. So being that this is a negative 18, we have to remember that we're going to use our negative on alternate sides of the t-table as we work through our factors. Negative 1, positive 18. Positive 1, negative 18. Negative 2, positive 9. Positive 2, negative 9. Negative 3, positive 6. Positive 3, negative 6. Okay, there are all of my pairs of factors. Let's go find the sum of each pair. Negative 1, positive 18, 17. 1 minus 18, negative 17. Negative 2 plus 9, 7. 2 minus 9, negative 7. Negative 3 plus 6, 3. 3 minus 6, negative 3. Which one of these sums did I need? Yeah, you got it. It's the negative 3 and the positive 6. Let's go put those in our wings. Negative 3, positive 6. So now we can build our binomials. T minus 3 over A. A has a value of 1. Great. And T plus 6 over A, which again is a value of 1. That's super. T minus 3, we just reduced. And T plus 6, we just reduced. Okay, so yeah, technically, these are still equal to 0. That's true. So this is the new part for today. Everything we've done on that problem is review. So the new part for today is let's set each binomial equal to 0. Solve for t. You've done the hard part. You're like closer than home stretch. Equal to 0. T plus 6 equal to 0. Add the 3. What you do on one side, do to the other. And t equals 3. Let's do it again. Minus 6 t equals -6. These are the two locations that this particular quadratic is going to cross the x-axis at -6 on the left and +3 on the right. That's it. You're good. Awesome. All right, why don't you pause the video and try to do number 4. Go. Let's go look at problem number 5 together. Now, in number 5, we said to begin with, these problems have to be equal to 0. This one's not. So let's make a note. Must be equal to 0. That's like a have to. So since it's not, we got to get it there. Let's go get it there. What do I have to do to that 5 to get it over on the left? Yeah, I got to add it. So these 5s cancel out, making a 0, which is what we wanted. Does this 5 add to the 6 and make an 11? Why not? The 6 has a variable of an m. The 5 does not have one. So they just say separate. M squared plus 6m plus 5. Great. All right, let's go do our factoring. Let's get some more room on our paper. You know, you can always use your margins to help you get more space to work in. So A is 1, B is 6, C is 5. I've got my box with my X in it. So my top triangle, A times C, what goes in there? Good, it's a 5. What goes in my bottom triangle? Good, it's a 6, because that's B. Now let's go make my t-table. It's a pretty short t-table. Got to make 5. There are not a lot of options. It's change colors. It's just 1 and 5. And that does have a sum of 6, which is really good. It's what we needed. So let's go build our binomials. M plus 1 over A. What's the value of A? 1. M plus 5, hello, over 1. That's an ugly, messy 5. All right, let's tidy this up just a little bit. M plus 1, M plus 5. So all of that is review. None of that is new, like at all. So what do we do that's new for today? Because we've done the hard part for sure. We are already done with the hard part. What do I have to do with each binomial now? That's right. Set them equal to 0. Solve for m. So m plus 1 equals 0. And m plus 5 equals 0. Let's solve. How do I solve for m? What do I do? Good. Subtract 1 on both sides of the river. M equals, yep, -1. Love it. So my other 0, my other root, my other solution, -5. Beautiful. All right, why don't you pause the video and tackle number 6. Let me know if you need some help. Let's go look at number 7. So the volume of a storage tub shaped like a rectangular prism is 24 feet cubed. All right. The height is 3. The width is W. And the length is W plus 2. Use the formula for the volume, length times width times height, to go find the value of W. All right. So volume equals length times width times height. And we have good information. We know that the volume is 24. So there's V. And I know that the height is 3. The width is W. And then the length is W plus 2. Let's go plug it in. So we said, what was the volume? What was V? 24. Great. What was the length? Good. It was W plus 2. What was the width? Yes, just W. And then the height? Yep, it's just 3. Okay, so let's multiply these two. 24 equals W plus 2. What is W times 3? Yeah, it's just 3W. So why did I want to do that? So that now I can go ahead and distribute this 3W into the binomial that's in front of it. So 3W times W, 3W squared. Because W times W is W squared. And then a positive times a positive is a positive. 2 times 3W, yep, 6W. Excellent. Now we said that in order to solve these by factoring, they have to be equal to 0. Is this one? No. So to make this equal to 0, we subtract 24 on both sides. Now some people get real nervous right about now and they say, I really would appreciate it if that 0 and equal sign was all the way on the right. That's fine, and we'll do that just so we kind of have some consistency with problems that we've been using. So 3W squared plus 6W minus 24 equals 0. Good. Factoring. So, do all 3 of my terms have anything in common that they are divisible by? Yeah, they do. What is it? 3. Good job. So let's divide that out of all 3 terms. 3 divided by 3? Yeah, it's just 1W squared. Positive. 6 divided by 3, 2 W's, minus 24 divided by 3, 8. Great. Good, good, good. Now we can get started factoring. What's your A? 1. B, 2, C, -8. Excellent. Let's go build our box with the X in it. Are you a master at this yet? I sure hope so. I really want you to grow in your strength and your confidence in knowing that you can depend on a pattern of behavior to be there for you so that you can be successful. Because that's what I want, is I want you to be successful in your learning, in your growth, in the achievements that are in front of you, just as you go about becoming an adult. Okay, so we have a -8. So remember, that tells us that the negative is sliding back and forth, alternating sides on my t-table. We need to figure out which pair is going to work for us. Which pair is it? Good job. -2, +4. That gets us what we need. -2, +4. Let's go build our binomials. So we've got W's. I've got W minus, actually I have a 3 all the way out in front. So -2 over A, which is 1. And W plus 4 over A, which is also 1. Let's tidy this up. 3, W minus 2, W plus 4. The hard part is over. Now, we have a little bit of a discussion. I have this 3, and we've been setting these pieces equal to 0. And you have a factored out 3. Can 3 equal 0? No. I don't care what it is. 3 anythings will not equal